going to do is I'm going to go over problems from the book from pages 71 through 77 on negations, showing you examples that have double negation, Modus Tollens, and indirect proof. And then after that, we'll get into a couple of problems that are actually going to be on quiz 4 that will prepare you for quiz 4. Okay, now I'm going to get into number 1, A through F. Let's see what we got. So the first one here, 1A, this is a quotation that most of you probably don't remember from the first President Bush, which is, "Read my lips, no new taxes." So, are there new taxes? T would be there are new taxes. Are there new taxes? No. So it's squiggle T. B, Notre Dame is not unbeatable, where B would stand for Notre Dame is beatable. So they're not unbeatable. So you might think, oh, that's a double negation. If they're not unbeatable, then they're beatable. Well, that's true. When we are doing translations, we're going to do exactly what's there, period. So I would italicize these elements for you, but it says that they're not unbeatable, which means squiggle, squiggle, B. They're not unbeatable. C, if the prosecution's case doesn't fit, you must acquit. Johnny Cochran, O.J. Simpson trial, early 90s. Most of you probably don't remember this, although they did American Crime Story, where you might have seen this recently. So it's an if-then statement, so that means there's an arrow. It says, if the prosecution's case doesn't, so if it does it fit, if it doesn't fit, then you must acquit. That's C. D, Bill Clinton, running for office, says this. Okay. 1D here. I experimented with marijuana a time or two, but I didn't like it. I didn't inhale, and I never tried it again. Okay, let's translate that one for Bill Clinton. So that would be 1D here. I experimented with marijuana. Let's just do it as it is. I experimented with marijuana a time or two, but I didn't like it, comma, I didn't inhale, and I never tried it again. Did he ever try it again? No, and he not ever tried it again. Okay, so that's it. Now, is this dyadic? No. So we have a couple of options here. Okay, since it's all dots connecting, it doesn't matter where we put the parentheses so long as it's dyadic. So one way we could do it, we could say this and this, and this and this. That's fine. What's also fine is saying, this and this, this, so this tiny left side and this big right side. That's fine. But we don't have to do that either. We do this and this, this and this. That's fine too. And we have a couple of other options, so long as it's dyadic. So I think the most basic one is if it's all ands, and make sure you get those squiggles for the elements in the parentheses. I think this is the most basic one to do. That's fine. Okay. E. Most of you don't remember this either, probably. Governor of New Jersey, Christine Todd Whitman, at the same time said, "Unlike the president, I inhaled." And then I threw up. Threw up is irrelevant. So what do we got? Unlike the president. So here's what we got. P stands for the president inhaled. W stands for I inhaled. And so we can say there, did the president inhale? According to the president, Bill Clinton, no, the president did not inhale. But unlike the president. So the president did not inhale. What did I do? I, Christine Todd Whitman, which was represented by W, what did I do? I inhaled. How do I say I inhaled? W. There's what we got. President didn't inhale, but I did. Okay, which is the same thing as saying, as it says here, unlike the president, I inhaled. Cool. F. If you're not confused, then you're not well informed. So that's an arrow. And here's what we've got. If you're not confused, so whatever follows if goes on the left side of the arrow. If you're not confused, then you're not well informed. Okay, so this is number 1, A through F. Let's look at the next batch. All right, so the next batch is going to be number 1, G through J. These are found on page 72. Oh, what do we got here? G says this. This is a quotation from Jean-Paul Sartre's Nausea. Okay, one of his plays. The cashier was not there, nor the waiter, nor Monsieur Fasquelle. So let me go ahead and say this. Nor, whenever you see nor, when it's by itself, it just means and not. So what that means is you're going to have a dot, and then later you're going to have a squiggle on something, whatever is following. When nor is by itself. There are other instances where we have nor where it's going to mean something different. If we see the word, I'm just going to go ahead and say this here, I'll put a little asterisk here. If you see neither in front of it, nor might mean something different once we get to disjunctions. We're not going to have to worry about that right now. For now, we're just going to say if you see the word nor, it's like not or. But I'm just going to say for now, if you see nor, it means and not. Okay? And not. Like I said later, if you see it in another context with disjunctions, it means something different. But just by itself, nor means and not. Okay? Just like unless means it's if not. Nor means and not when by itself. So let's see. With G, we've got this. The cashier was not there. So was the cashier there? No. The cashier was not there. Nor the waiter. So that means and not the waiter. Nor Monsieur Fasquelle, which means and not the Monsieur Fasquelle. Okay. It's done. Is this dyadic? No. So we have two options. We can have a heavy left, tiny right. That's perfectly fine. It's dyadic. It's all ands. It doesn't matter where. We could also put it here. Tiny left, heavy right. This is fine too. Just as fine as the previous example I gave. Okay. H. Now we shall have duck eggs unless it's a drake. Oh. What do we do with unless? First of all, put an arrow. And we say whatever's on the left, whatever follows unless goes on the left side of the arrow with a not in front of it. So unless it's a drake. So it's a drake, not. So if it's not a drake, then what? We shall have duck eggs. Because what is a drake? A male duck. And if you've got a male duck, if you you're not getting eggs, which means if you don't have a male, that is you have a female duck, then you get eggs. All right. So unless, or if it's not a male duck, a drake, then we can get eggs. Great. I. Hamilton can't preside without moving to city. Now I said this before. Without is something that means the same thing as unless. So that means we got an arrow. And whatever falls without goes on the left side of the arrow with a not in front of it. Okay? So Hamilton can't preside without moving to city. So without, like I said, is the same thing as unless, which means whatever follows without goes on the left side of the arrow with a not in front of it. So without moving to city, left side of the arrow, M with a squiggle in front of it. So if he doesn't move, then he, what? Then he can't preside. If he doesn't move, then he can't preside. Great. And then finally, J. All right, and this one's going to be confusing as it is. I'm not going to give you one like this, but I want to go ahead and go over it. J. The May Day program will be this Thursday afternoon, unless it rains. In which case, it will be Friday morning. So this one might be a little confusing as to what to do. So basically, we have two scenarios. Okay? Here's the way I want to put it. We have this. So actually, this is going to be a dot. It might not seem clear. It's a dot with two arrows. I'm going to go ahead and put these in parentheses. So here's what we've got. We've got in terms of what happens if it doesn't rain, and then if it does rain. So that's what's going on here. It might not be obvious, but that is. So what happens if it doesn't rain? Okay. Unless it rains. So let's take a look. The Mayday program will be Thursday afternoon, unless it rains. So if it doesn't rain, it will be Thursday afternoon. If it does rain, on the other hand, this means it will be Friday morning. So if it does not rain, it will be Thursday, and if it does rain, it will be Friday. How do I know that? Because what's going on in the lingo here. I'll say it again. The Mayday program will be Thursday afternoon. So it'll be Thursday afternoon, unless it rains. Okay, so here that would mean if it does rain, then it's going to be Friday. So this one's a bit confusing as it is. I wouldn't give you one like this, but this is what's going on here. Let's take a look at the next batch of the next three, K, L, M. All right, K says this. This is from Charles Dickens. Okay, K says the following. All right, this is from Christmas Carol. Unless I see with my own eyes and hear with my own ears, I never will believe it. So we can think of Scrooge here, saying like, if I don't see it and hear it with my own eyes, I'm never going to believe it. Not ever going to believe it, because that's what never means. So what do we got? Unless. That means whatever follows unless goes on the left side of an arrow with a not in front of it. What follows unless? Two things. I see it with my own eyes and hear it with my own ears. So unless this. That means this is a package deal with a squiggle in front of it. So unless this. So in other words, if I don't see it and hear it, then what? I never, not ever, will believe it. All right? L. Here's a quotation from, the illustrious Adolf Hitler. Not very quotable. Maybe someone you shouldn't go to, but nevertheless it's a demonstration here of a conditional statement with some negations in it. So what does he say? Hitler says here, boo-hoo, if I do not get the oil of my cup and Grozny, then I must end this war. Here Hitler's talking about the Eastern theater of World War II, and by Eastern here I mean the Eastern Front, like the front against the Soviet Union, not Eastern Front is in the Pacific Front, and he's saying if I don't get this oil and this oil, then I can't win. Aw, he can't win. So let's see what he's saying here. So in other words, he's saying the same thing as, unless I get my cup and Grozny's oil, then I gotta end this. So, what is that? So we got an arrow. If I do not get what? Two things. The oil of my cup and Grozny. If I don't get it, then what do I got to do? I got to end this. Got to figure out a way to end it. And like I said, boo-hoo, it's not going to happen. Okay, and then finally, M. M says this. If you don't take your money now, so this is the kind of thing you might see in a 401k program or something like that, like what are the details in there? Am I going to be charged for this? This kind of thing. If you don't take your money now, and you let it accrue till retirement, then our attorney has not helped you, and you will not be asked to pay a legal fee. Great. How do I translate that? It's this. If, so that means there's an arrow. Whatever follows if goes on the left side of the arrow. What's there? You don't take your money now. And. So we haven't seen a then yet or a comma, which means there's two things on the left side of the arrow. At least. If you don't take your money now, and you let it accrue to its retirement, then, so here's what's on the right side of the arrow, our attorney has not helped you, and you will not be asked to pay a legal fee. There you go. That's number 1M. What I want to do next is, you won't have questions like this on your next quiz, quiz 4, but I want to go ahead and go over what number 2 would say. So I'm simply going to say that here, what number 2 would say. Okay, like I said, you're not going to have one like this one on the quiz, but I want to go ahead and bring it out here in terms of what would happen. So, number 2, we've got, what's going on there? D would stand for Justice O'Connor as a Democrat. R would stand for Justice O'Connor as a Republican. Sandra Day O'Connor, Justice of the Supreme Court, well known in the early 90s when this book was written. How would you translate the following things? So first of all, squiggle, squiggle, R. This is one way we could do it. We could say it is, I think the easiest way to do it in English would say, it is not true. Okay, so there's one squiggle with that not there. It is not true that Justice, I'm going to abbreviate that with J, Justice O'Connor is not a Republican. Republican, not Republican. So there we go. And there's my, so look, two knots equals 2 squiggles, and R stands for she is a Republican. So there we go. B, squiggle D dot R. Okay, so here's how I put that. Justice O'Connor is not, there's that squiggle, and I'm going to abbreviate here, she's not a Democrat, but there's that and, is a R for Republican. C, we got this, squiggle D dot R. Here's how I put that. It's impossible. Alright, why impossible there? There's no word possible in there. The impossible here means you can't, you're basically saying you can't have this dot. You can't have this and. It's impossible for Justice O'Connor to be what? Both a Democrat and a Republican. So I'm abbreviating there, but that's what's going on here. This is saying she can't be both a Democrat and Republican. And finally, the last one, squiggle D. That is squiggle D dot squiggle R. Okay, Justice O'Connor is not a D for Democrat, so there's that one squiggle, and she is not a R for Republican. So look, there's 2 knots in there for those squiggles, so she's not this and she's not that. So that means she's something else. This early one, the C here is saying she can't be both. This is saying she's not this and she's not that. So the implication is there, maybe she's something else. Okay, let's take a look at the batch of number 3s now. Okay, let's take a look at 3A. So 3A here, we've got this proof. We don't have any translations to do here. We're trying to solve it. Here's the new rectified list. So first of all, we got this stuff. Arrow out, Modus Tollens, and out. All these are can questions. Can I do any of these? Do them. And, in, and double negation are should I do these? Like, we don't necessarily have to do them, but there might be situations where they're helpful. And then these 2 are really, can I do anything else? I'm just going to say really, in the sense of I can't do anything else, then do one of these, arrow in or indirect proof. These are emergency scenarios. Okay, which means for this quiz, we're probably going to have to do this one. Like the theme of this one is going to be indirect proof, double negation, and Modus Tollens because they're new. All right, so let's see what we can do. So first of all, what we're going to do is we're going to see, well, let's start at the top. Like, do we have any arrows not in parentheses? Yeah, we got 2. There we go. And this one. All right, do we have left side matches? Do you have a squiggle A somewhere? That would be the left side match for both. No. Okay, Modus Tollens. This one says, all right, do you have any arrows not in parentheses? Yeah, we do. Do you have the contrary of the right side here? Do we have a squiggle B somewhere by itself? Yeah, we do have a squiggle B here, but do we have a squiggle B by itself? No. What would be the contrary of squiggle B? That would be just vanilla B. Do we have B somewhere by itself? No. Okay, moving on. Do we have any dots not in parentheses? Nope, none to be found. Can and should we do an and in? Now, can we do an and in? Can we put these together? Well, we sure can. You could have squiggle A, arrow B, and squiggle A, arrow not B. That's not going to get us anywhere closer to A, so should we do it? Double negation. We can do a double negation. I'm just going to show it here. Like line 3, I could take line 1 and go squiggle A, arrow B. All right, I go squiggle, squiggle. Double negation, line 1. Not going anywhere, okay? So let's not do that. Let's not even bother with that. Now, that means we find ourselves in a situation where we try to do everything we can. E is now, then we move on to this. Arrow in. Is our goal an arrow? No, it's not. So what do we do in this situation? We can't do an arrow in. There's no arrow in to get. We do an indirect proof. So here's how indirect proof works again. You are going to, it's kind of like arrow in that you do a provisional assumption. But you do a provisional assumption for the contrary, or quote-unquote the opposite of whatever it is you're trying to prove, and you get two contraries and stick them together. Doesn't matter what the contraries are, as long as the mission works this way. This side quest works this way. You provisionally assume the opposite or the contrary of what you're trying to get, and you get any two contraries and stick them together with an and in. Like I said, in indirect proof, always the last move is always an and in, 100% of the time, no exceptions. All right, so let's do that. What's our goal? A. So for an indirect proof, what we do is this. We provisionally assume the opposite of that, or technically the contrary of that. So what's the contrary of A? Not A. So what we're doing is this. We're going to prove A by saying, let's just imagine for the sake of argument, squiggle A is true. Let's see if it leads to ridiculousness. If it leads to ridiculousness, that means that A then is true. That's how an indirect proof works. So we're saying this is a provisional assumption. And what are we trying to solve? Any contradiction. And the way I'm going to put a contradiction is a squiggle dot. Okay? That's what I mean by contra. Now, sometimes the technical symbol for a contradiction is, it looks like an upside down T. So I'm going to use that later on, but now you can think of it as this way. A squiggle and a dot. Okay? Something and the exact same thing, but not. That's what a contradiction is. That's what this symbol represents. Okay, so now with this squiggle A in play, that's what we're going for. So let's go back to the top of the list now. Can we do an arrow out? Yeah, we can do 2. Look, we got a left side match here with 1 and 3. We got a left side match with 2 and 3. What do we get? So I like to start at the top, so let's do 1 and 3. We get B, arrow out, 1 and 3, and we get squiggle B. Arrow out, 2 and 3. So then the temptation might be, all right, let's go arrow out. Let's see, can we do Modus Tollens? We can do Modus Tollens. We don't need to. Because you might think, oh, look, Modus Tollens. Look, right here. We got the opposite of the right side, which means you can get the opposite of the left. And that would actually be fine. You can go through that, and you'll actually solve the problem that way. We have no reason to do that because the mission was this. As soon as we started an indirect proof, the mission was get any two contraries that is the same thing and the exact same thing with a squiggle in front of it and stick them together. Do we have something and the exact same thing with a squiggle in front of it? We do. Look, we got B and we got B with a squiggle in front of it. That is a contradiction. Well, right now these are just contraries like floating here by themselves. So what we got to do is we got to stick them together. So this is an and in. And like I said, indirect proof always ends 100% of the time with an and in. So let's do it. We get B and squiggle B. How do we get that? And in 4 and 5. The indirect proof is actually now done. That was the mission. Provisionally assume the contrary of your goal and get something and the exact same thing with a squiggle in front of it. We did that, so it's done. So here's what this is actually saying. This is saying we know A is true. That's what we wanted to get, because if it's not true, then it leads to opposites being true. So really, again, the technical word here is contraries. Opposites is not actually accurate, but I'm going to use it colloquially because it kind of makes sense. All right, so if A is not true, that means B is true and not B is true. which means like something like, oh, then yeah, this way is up and this way is not up. That's stupid talk. Okay? In typical affairs. I can think of some exceptions. But for our purposes, up, you're saying up is up and up is not up. No, which means if that's what you're getting, then this is stupid talk, which means this is true. And that's actually what we do. In indirect proof, when this happens, if you provisionally assume something and then you get two opposites or two contraries, you can zoom out and say, well, that means this is stupid talk, which means this is true. So A is true. How? It's indirectly proven. So that's what indirect proof stands for. Where did we provisionally assume the contrary of the goal? Line 3. Where do we get two contraries and stick them together in a contradiction? Line 6. This one's done. So that's the mission. When you do an indirect proof, you provisionally assume the contrary of whatever your goal is at the moment, and then your mission at that point is to get any two contraries and stick them together. Doesn't matter how big the contraries are, how small they are, any two contraries can be stuck together. Okay, as soon as you see them. Like I said, here earlier, we might not have seen that we had two contraries, and then we could have done some Modus Tollenses, and we'd end up getting A out, and then we get A and not A, and we could have stuck those together. But we already had them here, so we didn't have to do that. So let's move on now to 3B. Okay, let's do 3B. 3B is actually pretty easy, relatively speaking. Let's do it. So first of all, we got C dot D. We want to find C dot squiggle squiggle D. All right. So you might think, oh, squiggle squiggle D. That's the same thing as D. Can't we just do a double negation on this? No, we can only do moves like that on the parts. So we're gonna break things down if we're gonna do that. So first of all, do we have any arrows not in parentheses? Nope. So we can not do arrow out or Modus Tollens. Do we have any dots not in parentheses? Yes. What does that mean? We break it apart. Line 2, line 3, we get C and D separately, and out on line 1 for both. Okay, at this point, can we do an arrow out? No. Modus Tollens? No. And out? No. And in? Yes, we can put those things back together. Does that lead anywhere? No. Can we do a double negation? Yes. We have D. One of the things we want to get is squiggle squiggle D. Saying this is the same thing as, well, not that. Yeah, that's equivalent. So what we're going to do here is we're going to squiggle squiggle D. So it's kind of like saying something's possible is the same thing as saying it's not impossible. That's what we're doing. Double negation on line 3. Okay, we can do it. Now, we've done this move. Arrow out, no. Modus Tollens, no. And out, no. And in, well, look, we want to get C and squiggle squiggle D. Do we have the pieces to build it? Actually, yes. There they are. Put them together. Look, C and squiggle squiggle D and in 2 and 4, and now this problem is done. This one didn't need a Modus Tollens. It didn't need an indirect proof. This one was using double negation to get what we want. Now, like I said, this thing is kind of the same thing as this thing, but not identical. This move allows us to demonstrate that it is identical and how we can change between these two things. Let's move on now to 3C. All right, let's talk about 3C. Now, 3C is a problem where it's not, according to the book, it's not exactly clear what you're solving for. I'm going to go ahead and say it's this explicitly. You've got assumption number 1, E arrow F. You've got assumption number 2, E and F, not. Okay, so not E and F. And then you've got, you're solving for squiggle E. Now, actually, I'll go ahead and say this right now. This is something that's going to be a lot easier later on in the semester, but for right now, we're only going to use the moves we've got. So let's see. First of all, do we have an arrow not in parentheses? Yes. Do we have a left side match? No. That would be arrow out. Modus Tollens. Do we have an opposite of right side? Do we have a squiggle left? No. Okay. Do we have any dots we can break apart? We got a dot in line 2. It's in parentheses. We can't do anything with it. Can we do an and in? We can surely bring these together. That's not going to get us anywhere closer to this. Just squiggle E. Okay. Can we do a double negation? Sure we can. We can say squiggle, squiggle, squiggle E dot F. We could also say squiggle, squiggle E arrow F. That's not going to go anywhere. Is our goal an arrow? Nope. So what do we do? Indirect proof. That's the move. So what do we do in indirect proof? we indent. Okay, like I said, these are assumptions. We're going to provisionally assume the opposite or the contrary of our goal. And our goal then is to get any set of contraries and slap them together in an and in. Period. So if our goal is squiggle E, what's the contrary of squiggle E? Just vanilla E. Okay, provisional assumption. There's a certain sense in which we could say, oh no, it's squiggle squiggle E, and then we double negate it and turn it into E. That's fine too. I think when we're doing this, we can just go ahead and do this. If we're translating, you want to say exactly how many squiggles are there. But if we're doing this kind of assumption, this is fine. So, provisional assumption E, what are we after? Any contradiction. And now I'm just going to use this symbol. So the upside down T means any two things, something and not the exact same thing. That's a contradiction. Let's go after it. Okay, so now we've got E. Go back to the top of the list. Can I do an arrow out? Yes. Now I can get F. Okay, so F. Arrow out, 1 and 3. Okay, and right here, stop. So when you're doing an indirect proof, you want to see, like, do I have something and its opposite? Because then you might think, like, oh, right now, like, oh, I can't do an arrow out, I can do a Modus Tollens. Well, no, you can't. But you might be thinking, oh, can I do an and out? No. Can I do an and in? Yeah, I could stick some things together. I could stick 1 and 4 together. I could stick 2 and Look here what you're trying to build. Any two opposites. And here's a bit of advice. If you're trying to build opposites, go ahead and look and see, what do you have with squiggles in front of it? So right now, I have in front of it, I have a squiggle, E.F. Nope. So what you want to look for after every move once you start an indirect proof is, can you build the exact same thing as something with that has a squiggle in front of it, just not with a squiggle in front of it. So look, we've got squiggle E.F. Can we build E.F? Yeah. We got E and F separately. So watch this. We build them. E.F. And in 3 and 4. And now look at line 5 and look at line 2. They are contraries. That is, here's E.F. and here's E.F, but nope. So what we do now is in line 6, we stick them together. We say, yep, if E is true, you get E.F and the exact same thing with a not in front of it. So this is actually and in lines 5 and 2. What can I do now? I'm saying this. If E is true, it leads to stupidity. Then this is true, and the exact same thing, but no is true. Okay, so up is up, and also up is down. No, that's stupid talk. So what we're saying is this. If this is true, it leads to ridiculousness, which means, indirectly, this must be true. Okay, so we can zoom out and say, hey, squiggle E is true. Because, indirect proof, if the opposite were true, as we provisionally assumed in line 3, it leads to ridiculousness like we saw in line 6. So yeah, that's what's going on here. This is like when you argue with a friend, again. You know, hey, if that's true, then that means that this leads to this, and that's stupid. Okay, you're saying something stupid. This is stupid. Triangles have 3 sides, and triangles don't have 3 sides. No. So if it leads to opposites, then this thing is not true, which means indirectly you prove that. Number 3C. Let's take a look now at 3D. Alright, let's take a look now at 3D, which your book has as like a 7-step process. We can actually be done by step 4. So here's an easy way to do it. And it's easier because we're going to follow the methodology that I have over here. Try this, try this, try this. See if you can do this, see if you can do this. And if you can't do any of those, give this one a shot and then give this one a shot. The only reason the book says something longer is because it doesn't apply this methodology. This is why if you apply this methodology, everything's going to go quicker. So let's see that here. So first of all, we've got squiggle G, arrow H. We want to get squiggle H, arrow G. Go through the numbers. Do we have an arrow not in parentheses? Yep, we do. There it is. Okay. Do we have a left side match? No. Do we have a right side contrary? No. Okay. Do we have a dot in parentheses? No. Do we have a dot we can build? Actually here, no. Do we have a double negation we can do? Yeah. We could say squiggle, squiggle, parentheses, squiggle G, arrow H, close parentheses. Let's not do that. All right, we can't do any of these things. We can't do any of the first 5. Is our goal an arrow? Yes, it is. So what do we do? This is what your book does not do. Line 2 here should be then, okay, what we're going to do is we're going to provisionally assume the left side. This is actually something from the last quiz. We're going to provisionally assume the left side, and we're going to try and get the right side. So what are we provisionally assuming? Squiggle H as a provisional assumption. What are we going to try and get? G, the right side. Let's do it. Okay, now with this in play, go back to the top of the list. Do we have an arrow out? No, we do not have a left side match. Okay? Modus Tollens. Do we have a right side contrary? Yes, we do. Look, we have squiggle G, arrow H. Do we have a contrary to the right side? We do. What does that get us? A contrary to the left side. Now the left side here is squiggle G. So what would be its contrary? Just plain old G. What's that? Modus Tollens 1 and 2. And check it out. What were we trying to get? G. We just got it like instantly. So the arrow in here is done. So what we can do is we can zoom out here in line 4 and say, yeah, if you got squiggle H, you totally get G. And watch this. Arrow in, it's the shortest arrow in you could possibly have. 2 through 3. Done. Arrow in, 2 through 3. Now there's a longer way to do this, but I'm not really going to go, it's in the book there, I'm not going to go over it. If you follow the steps in the order that you should, you get it this way. This is the way you should get it. Okay? Let's keep that in play. Let's now take a look at the translation exercises. We're going to start with number 4. Alright, now let's take a look at number 4 on page 73. It says this: Beethoven never played hockey. Okay, now for our purposes, that's going to be squiggle P, based on what's presented later. It says it's proof. So here's what are the assumptions that we have. We have number 1. If he had played hockey, he would have written hockey music. First assumption. Assumption number 2. Okay. However, he wrote no hockey music. Assumption number 2. So, with these assumptions in place, let's solve. Let's see. So we got these things. This. These are our moves. So again, this is the batch of can we do these, should we do these, in emergency scenarios do these. So first thing, do we have an arrow not in parentheses? Yes. Do we have a left side match? No. Okay, that's arrow out. Modus Tollens. Do we have a contrary of a right side? So right side of an arrow is M. We have squiggle M. So Modus Tollens says, remember the rule for Modus Tollens is this: you got an arrow, you get the contrary of the right side, you can get the contrary of the left side. So look, we have an arrow, we have a contrary right side, that means we can get a contrary of the left side. The left side is P, which means we can get squiggle P. Modus Tollens 1 and 2. That's what we're trying to get. This problem is done. Let's take a look at number 5. Let's take a look at number 5. It says this: a historic grist mill operating outside Tallahassee, Florida got caught in a bureaucratic catch-22 summarized in the following argument. The argument is actually exemplified on the top of page 74. It says this: the mill will grind corn only if changes mandated by the State Department of Agriculture are made. So, line 1. The mill will grind corn. So it will grind corn only if, that means write an arrow right over it, changes are made. And that's actually assumption number 1. But, remember that's a superfluous but when it's on the front of a sentence. So let's see, what's line 2? But the mill is on the National Register of Historic Places. So that's just R. Assumption number 2. Okay. And if so, that is, if it's on the Register of Historic Places, then what? Then no changes will be made. What kind, will it make changes? No changes will be made. Assumption number 3. Therefore, so this is what we're solving for, therefore the mill will not grind corn. Okay? So we're solving for squiggle G. Rules in play. These. Can we do these? Should we do these? And then in emergency scenarios, should we have to do one of these two things? Okay, let's see. First of all, do we have arrows not in parentheses? We got two. Okay, any left side matches? Yep. Third line, we got R on the left, we have R in line 2, that gets us squiggle C. Arrow out, 3 and 2. Okay, look again. Do we have any more arrow outs like we can do? Any more left side matches? No. Okay, Modus Tollens. Do we have any more right side contraries? Look at the right sides of the arrows. Do I have, like, I've got C here in line 1. Do I have an opposite of that or a contrary of that somewhere? Yep, I just got one in line 4. So Modus Tollens says this. You got an arrow, you got the contrary to the right, you can get the contrary to the left. Contrary to the left would be squiggle G. Modus Tollens 1 and 4, and that's what we were after, so this problem is done. Let's take a look now at number 6. Alright, now let's take a look at number 6. Now, number 6 on page 74 is kind of complicated, and basically we have the following two variables. We got T, which stands for black travelers are free to eat along the highway, and R stands for restaurant owners are free to refuse to serve black travelers. And here's what it's saying. Let's take the following assumption. Number 1. Okay. If T, if black travelers are free to eat along the highway, then it's not true that restaurant owners are free to refuse to serve black travelers. Assumption number 1. And we're trying to prove that this is demonstrating that the following two are incompatible. So then it can't be the case that both are, they're free to refuse to serve black travelers, and T, black travelers are free to eat along the highway. This is saying that then these two things are not compatible. Okay, what rules do we have in play? Arrow out, Modus Tollens, and out. That's a package deal. Then these two, and in, double negation, and then these two emergency case scenarios. Arrow in, and indirect proof. Let's do it. First of all, do we have an arrow not in parentheses? Yes. Okay. Now, do we have a left side match? Do we have a T somewhere? No. Okay. Modus Tollens. Do we have an opposite of the right side? Do we have an R by itself somewhere? No. Do we have a dot we can break apart? No. Do we have an and in we can make? No. Do we have a double negation that we can and should make? Can? Yeah, sure. We can put this whole thing and make it a double negation. No, that doesn't get us anywhere. Is our goal an arrow? No. So this leaves the final move here, indirect proof. What's our goal? Not R and T. So what are we going to do? We're going to provisionally assume the opposite of our goal. Since our goal is squiggle R dot T, we're going to provisionally assume the opposite. What would be the contrary? What would be the opposite or the contrary of not R dot T? Just plain R dot T. Okay, and the goal here is we're going to solve for any contradiction. It doesn't matter which one we get. Any two contraries, we're going to slap them together. So now, can we do an arrow out? No. Modus Tollens? No. And out? Yes, we have a dot, not in parentheses. That's going to break apart into two things. R and T. Both of those are and out on line 2. Now, you might be able to see it. We actually can do a Modus Tollens or an arrow out. Look, we got a Modus Tollens available, we got an arrow out available. I'm always going to say go with the top of the list first. Okay, can I do an arrow out? Do I have an arrow? Do I have a left side match? Yes, I do. That's going to get me squiggle R. Arrow out 1 and 4. Now, if I did the Modus Tollens instead, it's actually going to work out in the end. Okay? But I'm going to go with that. Arrow out. I've got a squiggle R. Now look, remember the mission is once you start an indirect proof, get any two contraries and stick them together. Do I have two contraries? Right now I do. Look, there's R, there's squiggle R. So stick them together. Remember, the last move of an indirect proof is always 100% of the time an and in. So I've got R and not R. And in 3 and 5. Okay? Side quest complete. Now look, this is saying this. If this is true, if R dot T is true, then it leads to R and not R being true, which is ridiculous. You can't have opposites be true, which means when we zoom out, it means the thing we originally assumed provisionally assumed must be nonsense, which means that the thing that we want to get after is true. This means that squiggle R dot T is true. How do we prove it? Indirectly. Where do we provisionally assume it's contrary? Line 2. Where do we get a set of contraries? Line 6. Let's take a look now at number 7. Alright, number 7 says this. Line 1. This is 7 on page 74. I can make Bannock for you. So if I make Bannock for you, then what? Or it says only if. That means there's an arrow. Only if the oven will get hot. Assumption number 1. Okay? Assumption number 2. The oven will get hot only if. That means there's an arrow. The electricity is on. E. Assumption number 2. 3. The electricity is on only if the power lines are up. Assumption number 3. But a tree brought down by a beaver fell on the power lines. That's just line 4. It's just F. Tree fell down. Okay, and line 5. If a tree fell on the power lines, so if F, then the power lines, are not up. Assumption number 5. And that is why, so solve for this, I cannot make Bannock for you. Okay? That's our argument here. What are the moves we have in play? Arrow out, Modus Tollens, and out. Those are the, if you can do them, do them. The maybe, if they go somewhere, these two, and in Double Negation. And then if you really must, arrow in and Indirect Proof. Okay, let's do the work. First of all, do we have any arrows not in parentheses? Oh yeah. Got 4 of them. Alright, do we have any left side matches? Yeah, we do. Okay, line 5 here has F on the left side of the arrow. We have an F in line 4. That gets us squiggle L. Okay, arrow out. 5 and 4. Okay, do we have any other left side matches that we can do? No. Next thing on the list, Modus Tollens. Do we have any contraries to right sides? Alright, so let's take a look at the arrows and look to see, do we have any quote-unquote opposites to the right side? Do we have a squiggle H somewhere? No. Do we have a squiggle E somewhere? No. Do we have a squiggle L somewhere? Yep, we just got it. So we can do a Modus Tollens then between lines 3 and 6. So Modus Tollens says, remember, if you got an arrow and you have the contrary of the right side, then what you get is the contrary of the left side. So look, I've got here in line 3 E arrow L. I've got not L. Okay, so I've got a contrary to the right side. That means I can get a contrary to the left side. That's going to be squiggle E. Modus Tollens 3 and 6. Okay, now with the squiggle E in place, can I do another arrow out? No, I don't have a B, I don't have an H, I don't have an E, I don't have an F, and so on. Well, I already had the F, so I use that. Do I have any contraries to the right side for Modus Tollens? Do I have a squiggle H? No. Do I have a squiggle E? Yeah, I just got one. So if I've got H arrow E and I've got squiggle E, that means I can get the contrary to the left side. That's going to be squiggle H. Modus Tollens. Where was the arrow that I used? 2. Where was the contrary to the right? Line 7. Okay, that's done. Now, can I do another arrow out? Do I have a B? No. H? No. E? No. F? We already did that one. Okay, Modus Tollens. Do I have any contraries or opposites to the right side? Okay, I've got an H here. Do I have a squiggle H somewhere? Just got it. So what does that mean? You got an arrow. You got the contrary of the right side. You get the contrary of the left side. The contrary of the left side of line 1 would be squiggle B. Hey, that's what I was looking for. How did I get it? Modus Tollens. Where was the arrow that I used? Line 1. Where was the contrary of the left side? I'm sorry, the contrary of the right side? Line 8. And now this problem is done. Let's take a look now then at number 8. Number 8 says this. Okay, line 1. Blanche was right-handed. Okay, line 1. That would just be R. Assumption number 1. Assumption number 2. 2 wounds were on the left side of her head. Ugh, this is grisly. Assumption number 2. Assumption number 3. If Blanche, so that first word if means there's an arrow. If Blanche committed suicide and was right-handed, so if she committed suicide and was right-handed, then what? She would not have wounds on the right side of her head. So in this case, she wouldn't have wounds on the left side. She would have wounds on the she wouldn't have wounds on the left side of her head. She would have wounds on the right side. So that's assumption number 3. Okay. Hence, so here's what we're solving for. Hence what? She did not commit suicide. Okay. Rules in place. Arrow out. Modus Tollens. And out. These are the, can we do these? These ones. And in. Double negation. Should we do these? And then finally, arrow in and indirect proof if we must. So these are the assumptions we have in play. We're going for this. Let's go about it. So first of all, do we have an arrow not in parentheses? Yes, we do. Okay. First thing we should do. Do we have an arrow out? Do we have a left side match? Do we have S.R? Nope. Okay, next thing. Modus Tollens. Do we have the opposite or contrary of the right side? Our right side of this arrow is squiggle L. Do we have a contrary to that? We do. L. Now, what does that tell us? That we can get the contrary of the left side. So the left side of this arrow is S.R. We can get, and we should, squiggle S.R. So remember, when you get a Modus Tollens, you have the contrary of the left side, you can get the, when you get the contrary of the right side, you can get the contrary of the left side, as we did here. So we can say Modus Tollens 3 and 2. Okay, great. Here we do an arrow out now. Modus Tollens now. And out? No. Any efficacious and in? No. Any efficacious double negation? No. Is our goal an arrow? No. So what do we do in this situation? Well, we need an indirect proof, which means we're going to provisionally assume the opposite of our goal. Now, or the contrary of our goal. Now, the contrary, our goal is squiggle S. So what we're going to do in line 5 is we're going to provisionally assume the contrary of that. We're going to say, we know squiggle S is true because we're going to just pretend here that S is true. It's contrary. And what we're going to do is we're going to go after any contradiction whatsoever. So now with that in play, we're going to see, can we do, and here's what I want you to look for. As soon as you start an indirect proof, here's the thing to look for. Remember, the last move is always 100% of the time going to be an and in. Do I have the pieces to build a set of opposites? So what you want to look for, yeah, we want to do arrow out. Can I do an arrow out now? No. Can I do a Modus Tollens? No. I already did one. Look and see. When you're doing an indirect proof, first of all, go ahead and look and see, do I have any knots right now? What squiggles do you have? Well, I got a squiggle here in line 4. This one I already got. It's squiggle S.R. Okay? If you got a squiggle, look and see if you have the pieces to build the opposite or the contrary of that. So we've got squiggle S.R. What would be the opposite of that? Just S.R. Do you have the pieces to build that? Look, line 5, S. Line 1, R. Put those together, you've got the contrary of line 4. So go ahead and start to build it. Line 6, S.R. And in 5 and 1. And then look at line 6 and look at line 4. They are contraries to each other. This means that the indirect proof is going to be complete. So look, I can say in line 7, hey, you can get S.R. and the exact same thing with a not in front of it. That's what a contradiction is. That's and in line 6 and 4, which means indirect proof complete. If we provisionally assume the opposite or the contrary of our goal, we get a set of contraries. Now, these are bigger, heftier contraries. That doesn't matter. Contraries can be as little or as big as you need them to be. Here, we have something and exactly the same thing with a not in front of it. That's all you need to complete an indirect proof, which means we can zoom out and say here in line 8, yeah, squiggle S is the thing. How? Indirect proof, because if you provisionally assume line 5, you will get crazy talk by line 7. What do I mean by crazy talk? S and R is true, and it's not true. Can't have contradictions. Law of non-contradiction. All right. Let's take a look at line 9, or number 9. Number 9. This is from Plato's Phaedo. Okay? Learning is actually recollection. Line number 1. Greek there is anamnesis. Anamnesis. It's related to our word amnesia. So Plato thinks that we don't learn anything new, we simply remember that which we've forgotten. Because in Greek mythology, when you die, one of the rivers you go across is the river Lethe, okay, that makes you forget. And so, actually, when you're born, it's your soul coming back into this world. And so for Plato, all of learning, everything that we learn, it's not something new that we learn. We're actually remembering something for when we're in the beyond, in his case, the world of forms. Okay, so learning is actually recollection. We don't learn, we remember. Line number 2, then. If that's true, if learning is actually recollection, then what we recollect now must have been learned before birth. Assumption number 2. Okay. 3. It is impossible that what we recollect was learned before birth unless the soul is immortal. Ooh. It is impossible that what we recollect was learned before birth unless. So remember, unless means there's an arrow, and whatever follows unless, it goes on the left side of the arrow with a squiggle in front of it. So what follows unless? Unless the soul is immortal. So look, since M would stand for the soul is mortal, we know that what's on the left side of the arrow is the soul is mortal unless it's not, which means we've got squiggle, squiggle, M. Let me tidy that up a little bit. Where on the left side of this arrow is the soul is immortal unless the soul is immortal. Squiggle, squiggle, M. Then what? Then that would mean that it's impossible, or it's not the case, that what we learned was learned before birth. Assumption number 3. So this one, the translation's a bit tricky. Okay, and then this. All right, now, given all that, prove this. So, the soul is immortal. So the soul is not mortal. Immortal. The soul is not mortal. Okay? This is the argument. What are the tools we have in place? Arrow out. Modus Tollens. And out. We got those 3 as a can you do it? And in. Double negation. If we should do these, we should do it. And then emergency case scenarios, arrow in, and indirect proof. All right, let's go about business. Okay, first of all, do we have arrows not in parentheses? Yep. Okay, can we do arrow outs? Yes, we can. We have an arrow here in line 2 and a left side match. That gets us what? B. Arrow out, 2 and 1. Okay, now, can we do another arrow out? No. Can we do a modus tollens? Do we have an arrow and the contrary of a right side? No. Here we got a match here. Oh, but yeah, in line 3 we have the contrary. So remember what modus tollens says, so to speak, is if you got an arrow and you got the contrary of the right side, you can get the contrary of the left side. So take a look at this. Here we've got squiggle, squiggle M, arrow, squiggle B. We've got B. So that's the contrary of a right side. So we need to figure out what would be the contrary of squiggle, squiggle M. Now we have 2 options here, and in this case, I would accept either one of them. One option we could say is, what's the contrary of squiggle, squiggle M? And the answer could be squiggle, squiggle, squiggle M. I would accept that, except there's something simpler that we can put in this case. Since we know here, now this is not true when we're translating, but when we're doing deduction, okay, what's the contrary of squiggle, squiggle M? Well, we can say squiggle, squiggle, squiggle M. We could also just say squiggle M. I would accept either one. I think here it's easy to say what's the contrary of squiggle, squiggle M. Let's go ahead and say squiggle, squiggle, squiggle M. Okay? Modus Tollens, 3 and 4. Now here with this, okay, this is not the simplest way we can put it. Let's go down the list. Arrow out, no. Modus Tollens, no. And out, no. And in, no. Double negation, yes. And in fact, double negation is going to cancel out 2 of these squiggles. Because remember, if you have an odd number of squiggles, it's the same as having 1. So what does that reduce down into? Just plain old squiggle M. Double negation, line 5. Hey, that's what we were after. This problem, therefore, is done. Let's take a look then at number 10. All right, number 10. Let's look at the reduced form of the argument on the middle of page 76. Here's what we got. Line 1. Or's asking to be grounded is proof of his sanity. We'll translate that another way. If he asks to be grounded, then it would be necessary that he's sane, which means A arrow S. Assumption number 1. Again, these translations are a bit tougher. Okay, asking to be grounded is a necessary condition for being grounded. So remember, necessary conditions go on the right side of the arrow. So in other words, if he's grounded, then it'd be necessary that he have to be asked to be grounded. Okay, because that's what necessary conditions are. Great. 3. If Or is sane, if he's sane, then he cannot be grounded. Assumption number 3. All of it shows that Or cannot be grounded. Okay, moves in place, arrow out, Modus Tollens, and out, package deal. We got and in and double negation, and then emergency scenarios, arrow in, and indirect proof. Let's do the work. First of all, do we have arrows not in parentheses? We have a trifecta hereof. So look, 3 arrows not in parentheses. Okay. Any left side matches? Do we have an A? Do we have a G? Do we have an S? Nope, nope, nope. Okay. So go down the list. Arrow out? No. Modus Tollens? No. And out? No. And in? Let's not. Double negation? Let's not. Is our goal an arrow? No. So what do we do in this situation? Our goal is not an arrow. Nothing else to do. Provisionally assume the contrary of the goal. Our goal is squiggle G. So what we're going to do is we're going to provisionally assume just plain old vanilla G. And we're going to say, hey, let's get any contradiction. Any 2 contraries, let's slap them together with an and in. That's the mission. Okay, and we do that with this in play now. So now, can we do an arrow out? Yeah, look, 2 and 4. There it is. We get A, arrow out. 2 and 4. And now we can do another arrow out. We get S. Arrow out 1 and 5. And now look, with the S, we get another arrow out. We get squiggle G. Arrow out 3 and 6. And right when we get that, look, now we have squiggle G and G. Now remember, the mission is, as soon as we provisionally assume G, the mission is get any 2 contraries and stick them together. We have the pieces to do so. G and squiggle G. Stick them together. G and squiggle G. And in. 4 and 6. And remember, the last move in indirect proof is always an and in. So look, we did it. We provisionally assumed the contrary. We got a contradiction. So now what we do is we zoom out and we say what we did. Yeah, you can say squiggle G because, now wait, you might be thinking here, wait, we were trying to get squiggle G. We got it in line 6. We could have stopped right there. No, and here's the reason why. Because here we're still in the side quest and we have to fulfill the conditions of the side quest. The side quest says, so to speak, once you provisionally assume the opposite, you have to get 2 opposites and stick them together. Once you provisionally assume the contrary of your goal, you have to get 2 contraries and stick them together. So you might be tempted to say right here in line 7, hey, but we got the thing we're looking for. No, you didn't, because this isn't a side quest. This is completely separate from the main scenario. This is something else entirely. You did not get it. This is like having, you need $100. Well, you've got $100 in Monopoly money. You do in the side quest, you don't have it in real life. Here we've got not G in real life, so to speak, out in the main quest. How? Indirect proof. Where did it start? Line 4. Where do we get the contraries? Line 8. Because again, don't get distracted by what you need. Fulfill the mission that you're on at the time that you're on it. Okay? Let's take a look at number 11. Alright, let's take a look at a version of number 11. So here's what we've got. I went ahead and translated it up here for you to get ready to go. Arrow out. Do you have arrows not in parentheses? Yeah, we got 2. And left side matches? Nope, nope. Okay. Modus Tollens. Do we have any right side contraries? Do we have a squiggle D by itself? No. Do we have an A by itself? No. Okay, moving on. And in. It's not going to go anywhere. Double negation. It's not going to go anywhere. Is our goal an arrow? Yes, it is. This hasn't really happened yet. What we're going to do, we're going to provisionally assume the left side of the arrow, and what we're going to try and do is going to get the right. Okay, so let's do that. Line 4, provisionally assume A. Okay, so here's the mission. Provisionally assume A, get squiggle C, the right side of the arrow that we had up here. Let's do it. Now with that A in play, can we do an arrow out? No. Can we do a modus tollens? Do you have is this the contrary to a right side? Yes, it is. So look, line 3 and line 4. Look, line 3, we've got squiggle A on the right side. Number 4, our line 4 is its contrary. So that's going to get us squiggle D, not B, but squiggle D, modus tollens 3 and 4. Okay. Now with the squiggle D in play, can we do another arrow out? Can we do, or just that? Can we do an arrow out now? No. Can we do another modus tollens? Yeah. This is the contrary of the right side of line 2. What does that get us? The contrary of the left side. And the left side there is C dot B. So the way contraries work, it's the exact same thing with a not in front of all of it. Okay? So what we get here is this. Squiggle C and B. Again, that's modus tollens 2 and 5. Alright, let's look again. Can we do an arrow out? No. Modus tollens? No. And out? No. And in? Doesn't go anywhere. Double negation doesn't go anywhere. Is our goal an arrow right now? Remember, our goal right now is squiggle C. Go anywhere? No. Is our goal right now an arrow? Squiggle C? No. So what are we going to do? We're going to start an indirect proof. Our goal right now is squiggle C. What we're going to do is here in a subproof, we're going to say, hey, let's provisionally assume the opposite of our goal. Our goal is C. We're going to say, or our goal is squiggle C, so we're going to provisionally assume C. And the goal then is get any contradiction whatsoever. So now with the C in play, what can we do? Now take a look. So as soon as you start indirect proof, you want to see, remember the last move of an indirect proof is, do you have any contraries that you can put together? So look, and the first thing you want to look for is, what do I have that's already sitting there with negations in front of it? So look at line 6. Line 6 is not C dot B. So look, first of all, can I build the opposite of that? Could I build C dot B? Look, I've got C, I've got B. So watch this, line 8. C dot B. And in 7 and 1. And look now, line 8 is the contrary of line 6. I'm just going to slap these together. Watch this. C dot B and the exact same thing with a not in front of it. And in line 8 and line 6. I did it. Look, already. So I can zoom out here and say line 10. Yeah, if you provisionally assume C, you'll get a contradiction, which means squiggle C is true, indirectly. 7 through 9. Which means then, look, squiggle C was the thing I was trying to get with this arrow in here. Which means if you provisionally assume the left, you get the right, which means I can zoom out here and say, yeah, if you provisionally assume this, you get this, which means I can zoom out from this and say in line 11, yeah, if A is true, then you totally get squiggle C, which is what I was trying to get up here. How'd I get this one? Arrow in. This started in line 4. It completed in line 10. So this is a indirect proof inside a conditional proof inside a standard proof. Okay? Let's take a look now at number 12. Okay, now let's take a look at number 12. Here's what we got. It says this. Representative Forbes voted legally only if he was in Tallahassee when the vote was taken. Okay? So he voted legally only if, that means there's the arrow, only if he was in Tallahassee when the vote was taken. You know, hashtag Florida. Okay, cool. 2. Therefore, since he was in Jacksonville at the time, he did not vote legally. Since the therefore is there, that lets us know that's what we're actually solving for. So what are we solving for? If he was in Jacksonville, then he did not vote legally. So that's what we're solving for. But then it says this. Obviously, so here's the next assumption it's adding. Obviously, he was not in both cities when the vote was taken. So it's doing this thing. He cannot be both in Jacksonville and Tallahassee. Can he be in both? No, he cannot. That's assumption number 2. That's the translation. Let's go for it. We got these moves in play. Arrow out, Modus Tollens, and out. So trifecta. We can do and in and double negation if it's necessary, and then if we really need to, we can do arrow in or indirect proof if we really need to. Alright, let's do the work. Can we do an arrow out? We got an arrow not in parentheses. Do we have a left side match? Nope. We have a right side contrary. No. So can't do arrow out, can't do Modus Tollens, and out. This dot here is in parentheses. Can we do an and in? Yeah, it's not going to go anywhere. Double negation? Yeah, it's not going to go anywhere. Is our goal an arrow? Yes, it is. Which means what are we going to do? We're going to provisionally assume the left, and we're going to solve for the right. So we're going to indent. I'm going to say, hey, let's provisionally assume J. And we are going to provisionally assume J, and we're going to try and get squiggle L. Alright, now with that in play, can we do an arrow out? No. Can we do a Modus Tollens? No. Can we do an and out? No. Can we do an and in? Yeah, but it's not going anywhere. Can we do a double negation? Yeah, but it's not going anywhere. Is our goal an arrow right now? Remember, our goal right now is squiggle L. No. So what are we going to do? This is our goal right now. We're going to do an indirect proof. So we're going to indent on another level. So our goal is squiggle L. So what we're going to do is we're going to provisionally assume the contrary of that. That's L. Provisional assumption. Now here we're doing an indirect proof. So what we're going to do is we're going to solve for any contradiction. Doesn't matter what we get. And once we get that, any contradiction, the whole rest of the thing is going to unravel. So now let's see, can we do an arrow out? Yeah. This is the left side here. That gets us T. And remember, what we want to do, we get arrow out, 1 and 4. We want to get any two opposites and stick them together. Any two contraries and stick them together. So what you should scan for, or what negations do I already have? I have squiggle, J, and T. Can I build the opposite of that? The opposite of squiggle, J, and T would just be J and T. Can I build J and T? Uh-huh. There are my pieces. So look at this. Line 6. J dot T. And in 3 and 5. And then what I can do is, look, I can say that thing and exactly not that thing. So look, I get J and T and squiggle J and T. How did I get this? So look, and in, J and T came from 6. Squiggle J and T came from 2. there are my contraries. So I can zoom out here and say, yeah, if you provisionally assume L, you will get crazy talk, which means that squiggle L is true, albeit indirectly, 4 through 7. But look here, if we provisionally assume the left, we get the right, which means when we zoom out, we can say, hey, you got J, you can get squiggle L. How? Arrow in, 3 through 8. Number 12 is done. Let's take a look at number 13. Number 13, page 77, says this. If Colin Powell is the President of the United States, then he is a citizen of the United States. Assumption number 1. Okay, in fact, only assumption. So conclusion for us here is if he is not a citizen, then he cannot be president. Okay, prove it. Okay, here we go. Remember, moves in play, arrow out, Modus Tollens, and out. Okay, then we got and in, double negation, and then last but not least, arrow in and indirect proof if we must. So let's see, do we have an arrow not in parentheses? Yeah. Can we do an arrow out? Do we have a left side match? No. Do we have a right side contrary? No. Do we have a dot we can break apart? No. Do we have anything that we can build in with an and in? No. Double negation? Yeah, that doesn't go anywhere. Is our goal an arrow? Yes, it is. Okay, so what we're going to do is we're going to provisionally assume the left side and solve for the right. So line 2, provisional assumption, squiggle C. That's a provisional assumption. And we are after the right side of the arrow, which is squiggle P, the right side of the arrow of our goal. Now, look at this now. Can we do an arrow out? No. Can we do a Modus Tollens? Yes. Look, we got an arrow. And the contrary of the right side, what does that mean we can get? The contrary of the left side. What would that be? Squiggle P, which is exactly what we wanted to get here. How do we get it? Modus Tollens, 1 and 2. But this also means instantaneously our arrow in is done. We provisionally assumed the left side and got the right side, bam, like that. Which means we can zoom out and say, yeah, if you got squiggle C, it will totally lead you to squiggle P, in this case instantaneously. How did we get it? We stuck an arrow in there. It started in line 2, it ended immediately in line 3. And that means number 13 is done. Let's take a look at number 14. Right, number 14 is an argument for the existence of God that occurs in Anselm's Proslogion from about 1,000 years ago. Here's what it says. God exists in reality. Now, I know that's actually the conclusion because it then says the proof, which means following the proof, these are the premises. So premise number 1, God is a being greater than that which can be conceived. So God is the greatest thing you can think about. Assumption number 1. Assumption number 2, we understand the term God. So even if you're an atheist, when you hear someone say God, you get what it means. Okay, line number 3. If we understand this term, so if you understand the term God, then God exists in the understanding. Assumption number 3. Assumption number 4. Okay. If God exists in the understanding, but not in reality, so if he exists in the understanding, but not in reality, so if it's a term that we can understand, but it doesn't really exist, then God is not the greatest conceivable being. That's squiggle G. Assumption number 4. Okay, so what's the argument then? That God exists in reality. So these 4 assumptions, God exists in reality. Prove that God really exists based on these assumptions. Okay, for Anselm. Okay, so let's take a look. Remember the moves we have in place? Arrow out, and out. Let's see, no, I'm sorry. Arrow out, Modus Tollens, then and out. Okay, we got those. And in and double negation, and then we've got arrow in and indirect proof if we need them. Alright, so let's do it. First of all, arrows not in parentheses. We got 2 sets. Here and here. Do we have any left side matches? Immediately we do, which means we're going to get U. Arrow out, 3 and 2. Okay. Can we do another arrow out? No. Can we do a Modus Tollens? Actually, yes. We have an arrow. The right side of the arrow is squiggle G. We do have a contrary in line 1, which means we can get in line 6 U dot squiggle R. Not that. Modus Tollens 4 and 1. That's actually going to come in handy here in a minute. Now, is there anything else we can do? Arrow out? No. Modus Tollens? No. And out? Again, both of these dots are in parentheses. We can't use them. And in? Nothing's that's going to get us to R. Double negation? It's not going anywhere. Is our goal an arrow? No. So what do? We're going to provisionally assume the opposite of our goal. We got R. Let's provisionally assume in line 7. Squiggle R. And the mission, the side quest at this point is then get any set of opposites and stick them together. So now with this squiggle R in place, yeah, we could say, all right, can we do an arrow out? What you want to look for immediately is that, do I have, what are the squiggles that I already have, and can I go ahead and build the opposite? So look in line 6. We've got squiggle U dot squiggle R. Can I build the contrary of this? Like, could I build U dot squiggle R? And yeah, I can. Look at line 5 and line 7. There's U and squiggle R separately. So watch this. I built them together. U dot squiggle R. And in 5 and 7. And then look, now line 8 and line 6 are contraries, which means I have a contradiction. It's bigger than some of the other ones that we've dealt with, but look, I've got U squiggle R and the exact same thing, U dot squiggle R with a squiggle in front of that. Those are opposites. Those are contraries. So I can say and in line 8 and line 6. So I can say, yeah, you provisionally assume squiggle R, you get crazy talk. So that means if you say God doesn't exist in reality, you get a contradiction. That's exactly what Anselm says in the argument. If you say God doesn't really exist, you end up getting a contradiction. Because you end up basically saying that God's the greatest thing that exists, but if he doesn't really exist, then he can't be the greatest thing that exists. That doesn't make any sense. What does that mean then? Line 10. Then God really exists. How? Indirect proof. 7 through 9. And this is an argument that you can actually look at in the Proslogian chapters, I want to say chapters 2 through 5 of the Proslogian, and that's actually the exact argument. That God can't not exist, because if he doesn't, then the concept God doesn't make any sense. The argument actually is a very clear indirect proof. So there you go. But then let's take a look at number 15, which is another argument about the existence of God. That doesn't say God doesn't exist, but that the notion of God is inconsistent. Let's take a look at number 15. Number 15. Let's take a look at what we got here. Another argument about not the existence of God, but about the notion of God. So here's what we got. Number 15. Challenge to theism. I'm going to kind of translate it for us, because the translation here is not entirely clear. So line 1. If God is all loving, okay, then he must wish to abolish evil. And if he is all powerful, then he must be able to abolish evil. Premise number 1. Assumption number 1. Assumption number 2. If he is willing and able, then evil would not exist. But evil does exist. Assumption number 3. So it must be the case then that it can't be the case that God's powerful, all-powerful, and all-loving. He can't be both. He's got to be one or the other. So let me refresh the argument. So here's what it's saying. If God is all-loving, then he wants to get rid of all evil. And if he's all-powerful, then he has the ability to get rid of all evil. So if he's willing and all-powerful, then evil shouldn't exist. But it does. So then, God can't be all-powerful and all-loving. Maybe he's one or the other, but he can't be both. That's the argument. Let's see if it's valid based on these assumptions. So remember, we got a couple moves in place. Arrow out, Modus Tollens, and out. That's set. second set, and in, double negation, and then third final set, can we do arrow in, indirect proof? Let's see what we got. So first of all, arrow not in parentheses. Can we do anything with this? Do we have a left side match? No. Do we have a right side contrary? Yep, we do between lines 2 and 3. Look at that. Okay, don't miss those. So that gets us, if we got an arrow, we get the contrary to the right side, we get the contrary to the left. The left here is W dot A. So remember, when you're writing contraries, just write the exact same thing with a squiggle in front of it. Modus Tollens, 2 and 3. That's going to come in handy in a little bit. Okay, go back to the top of the list. Can I do an arrow out now? No. Modus Tollens now? No. And out? Yeah, that's been there. But that was the third item on our list. So let's do that. We get line 5, line 6. That's going to be freed from parentheses, L arrow W and P arrow A. And out on line 1 for both. Okay. Now, do we have arrows not in parentheses? Yeah, we got 2. Here and here. Left side matches. Do we have any L's anywhere? No. P's anywhere? No. Squiggle W's for Modus Tollens? No. Squiggle A for Modus Tollens? No. Any more end outs that we can do? No. Any end ins that we should do? No. Any double negations that we should do? No. Is our goal an arrow? No. Our goal then is P dot L with a not in front of it, so we're going to provisionally assume the opposite of this, the contrary of this. What's the contrary of not P dot L? Just plain P dot L. So we're going to provisionally assume this, and here's what we're going to say. We're going to say, all right, since we're provisionally assuming this, get any two sets of opposites and stick them together. So now with this in play, P dot L, can we do an arrow out? No. But look, this is a fresh new dot that we can break apart. 8, 9, we get P and L separately. Okay, and out on line 7. And out on line 7. Can we do an arrow out now? Yeah, we get A. Look at it. A. Arrow out. 6 and 8. And look, we also get W. Arrow out. 5 and 9. Now, for the sake of space, now I will keep going. So if we get that A and W, so what can I do now? Well, remember, when we're doing an indirect proof, one of the things we want to look for is, do I have any opposites? So look for already the squiggles that you've got. I've got squiggle W dot A. Do I have the pieces to build the opposite of that? I literally just got them. So I'm going to move this over here. Actually, this one line I'm going to do here. So look, I can get number 12, W dot A, and in 11 and 10. But now look, 12 and 4 are contraries. So I can say here, line 13. I'm going to move it over here. If I had more space, I would keep going in this line. So I can write large enough that you can read it. I'm going to do it over here. But think of it as under here. Line 13. Look, W dot A and not W dot A. What is that? And in 12 and 4. So what happened there? Look, I provisionally assumed starting here in 7, and it led all the way to line 13. So I can zoom out now and say on line 14, hey, if you start with P and L, it leads to ridiculousness. You get a world where W and A is true. God is willing and able and not willing and able. Well, that's stupid talk. So what does that mean? Well, that means that then, can God be all-powerful and all-loving? He can't be both those things. Maybe he's one or the other, but he's not both. How? Indirect proof. Where did we start doing that work? Line 7. Where did it stop? Line 13. Alright, so these are the problems from the book. What I'm going to do next in this video is I'm going to show you a couple of problems from Quiz 4. We're going to go over a couple of sample problems, and that will get you set up for doing quiz 4. Let's take a look first of all at those sample problems in general. What I'm going to do now is talk about these following problems from quiz 4. So these are going to be 4 that are actually on the quiz, and so we've got these. So here's how they're going to appear actually on the quiz. So here I've got the italicized elements on here indicating negation. So we don't, there's an nt there, we don't park on parkways, yet we don't drive on driveways. If all of this is true, then English makes no sense. So there's all this considerate text here. All right, so that's a negation, that's going to be a squiggle. There is a negation, that's going to be a squiggle. There is a negation, that's going to be a squiggle. And the way I've got these, you notice I've got these big beefy semicolons. What that means is this. Okay, so sometimes these giant semicolons are not grammatically correct, but I'm using them to let you know, hey, look and see how much stuff you have on either side of this. If you have 2 things on either side of this, that means those things get grouped together. So for example, this semicolon here, how much stuff is on the left? Oh, there's this, yet this. That means those things go together in parentheses. How many things are to the right of this? Just 1. So this thing's by itself. Okay, on the other hand, take a look at this one. This semicolon here. How many things to the left of it? 4. That means there's going to be braces. Okay, so if it's just 2 elements, that would be parentheses. 3 elements would be brackets. 4 elements is going to be braces. So you're going to see braces there. Okay, and then to the right of it, only 1 thing. Okay, so keep that in mind. Then we've got an argument here, so this is one that we're going to have to translate and turn into a proof, and then we just have a plain old proof. All right, so this is what they're going to look like on the quiz. Now I'm going to get into showing you how to do each one of these problems. There are actually going to be ones on quiz 4 and are indicative of the kinds of problems that you'll see on quiz 4. All right, let's deal with the first one, and what I'm going to do is I'm going to highlight some things in here as we go to let you know that we need to do something with it. So let's look at this. So we don't, so that nt there, that's a negation. We don't park on parkways. Let's try to put that in a straight line. So we don't park on parkways, so that's one of our pieces. Yet, that means we need to do something with this. That means and. We don't drive on driveways. Now here's one of those semicolons. That means, look at this thing right here. Okay, if you've got more than 2 things to the left of it, those 2 things are going to go together in parentheses. So basically that means this is going to be a thing. Parentheses are going to be here like this. And look to the right of it. If all this is true, then there's some more connective language. That means, hey, there's an arrow over here. If all of this is true, which means all of this stuff that came before is on the left side of an arrow, then English makes, a no sense. So how do we translate that? Basically, now I'm just going to take these pieces and turn it into formal language. So I already know that there's going to be parentheses here. And I know all of that stuff in parentheses on the left is on the left side of an arrow. What's in here? We don't park on parkways. So we don't park on parkways. Yet, that means and. We don't drive on driveways. We don't park on parkways. We don't drive on driveways. If all this is true, then English makes sense. Does it make sense? No, it doesn't. So that's this one. We don't park on parkways, yet we also don't drive on driveways. And if all this is true, then English makes no sense. Okay, that's the first one here from quiz 4. Now, that doesn't mean it's number 1 on the quiz, but that's one of the ones on the quiz. That's just a translation. Let's look at the next one. Okay, now let's take a look at this one. We've got, all right, there's if. If you press Control, that's a thing, comma, Alt, comma, and, that's connective language, delete. Now this is a list. Now since it's a list here, Control, Alt, and delete. What that means here is this comma here is also functioning as the same thing as this. That means there's 2 dots here. There's an and here and an and here. All right, so those would be the dots there. So if you do this and this and this on your computer, and then there's that comma there, that means the then is here, even though it's not stated. It's implied. So all this stuff is on the left side of an arrow. Okay, so if you do all this, then what? You'll open the task manager. Ooh. But then we've got this. Here's that semicolon, which means all this stuff is actually itself grouped together. So let's take a look what we got. We know that means we've got there's 4 items here. We know we're going to have braces outside the whole thing. How do I know that? Because we're going to have brackets around this. And then since this is all ands in here, I can either put parentheses around the control and the alt, or the alt and the delete. It doesn't matter which. I'm going to go ahead and do it this way. So I can put parentheses around that. That's fine. Ooh, unless. Unless means whatever follows unless goes on the left side of the arrow with a not in front of it. But let's look at what we got. You're not using Windows. So whatever follows unless goes on the left side of an arrow with a not in front of it. So this means here's what we got here. This one's a little bit complicated, but it's doable. And I'm literally telling you what it is now. So let's take a look. So whatever follows unless goes on the left side of an arrow. So let's draw an arrow. Whatever follows unless goes on the left side of an arrow. What goes on the left side of the arrow? You're not using Windows. But whatever follows unless goes on the left side of an arrow. There it is, squiggle W. With the unless means there needs to be a squiggle in front of that. So that means we got two squiggles here. Now you might be thinking, oh, isn't that the same thing as having no squiggles? It is, but when you're translating, put it exactly as it is. Don't deduce from there, oh, that means this. I can just put W here. Nope, put it exactly like how it is. In a proof, I could tell you that you could change that. Okay, and then I said, on the right side of the arrow, we have all this stuff in braces. It's going to be a ton of stuff. Okay. In fact, I'm going to leave that closed brace. I'm not going to put on there until I get it all in so it looks tidy. So what's in here? Well, the first word I see is if. That means there's another arrow inside here. And up to this point, I said this is where the then is. So all of this stuff in here is on the left side of the arrow. So what's that? If you press Control and, because that's what that comma means there, and Alt, and delete. So this is what's on the left side of an arrow. Now it's all ands. So is this dyadic? No, we have to group it together, but it doesn't matter. We can put the parentheses around the A and the D. That's perfectly fine. Or we could put the parentheses around the C and the A. I'm going to go ahead and do that, but it doesn't matter. Either one of those is fine. And then what follows on the right side of the arrow would be, if you do this and this and this, then you'll open the task manager. So hey, that's where the braces are going to end. But then, hey, if this is the left side of this arrow, this is not dyadic either. So this arrow is not dyadic. Look, I got something over here, and something here, and something here. So actually, all that stuff on the left side of the arrow needs to be grouped together. That's what the brackets are for. And now look at this. This is dyadic. So look, well, if I zoom all the way out, here, this is the left side, and this is the right side of this arrow. Okay? But then if I zoom in to this side, if I zoom into just the right side and look at this arrow, here's the left side, here's the right. That works. And then if I zoom into the brackets, here's the left side, here's the right side. That's dyadic. And even if I zoom into these parentheses, here's the left side, here's the right side. So that's dyadic. And so thus this is a well-formed formula. Now actually I also have a document on Blackboard too that's attached to your quiz 4 that goes into more detail about what to do with a problem like this. In fact, with this exact problem. So how to figure out how do the braces work, how the brackets work. So it's a little bit more in-depth than what I'm doing here. Here I'm just being very straightforward. If you want to know all the nuances, take a look at that explanatory document that's attached and tethered to quiz 4. But this is the answer to this one on quiz 4. So here's what it's saying. It says unless you're not using Windows. So yeah, it's the same thing as saying if you're using Windows, then if you press Control Alt Delete, you'll open the task manager. Okay, so if it's not the case that you're not using Windows, so if I'm using Windows, unless you're not using Windows, so that means if you're using a Mac, if you press Control Alt Delete, is that going to open the task manager? No. So that's what that unless you're not using Windows means. So in other words, if you are using Windows, then this stuff is true. If you're not, if it's not the case that you're using Windows, then stuff is not true. So that's what this is saying here. Basically, the same thing as saying if you're using Windows, then this stuff works. Implication being, if you're not using Windows, this stuff is not going to work in this way. You can't press Control Alt Delete on a Mac in the same way, or on other non-Windows devices. Try doing that on your Android phone. It's not going to happen. Okay, even if there were Control Alt and Delete on your keyboard, you could press all three at the same time. It's not going to open up the Task Manager because that's a Windows feature. Okay, let's take a look at the next one that I've got for us. Okay, now this one is not just a translation. This is a translation, and we have to do a proof for it. So let's go through. We've got one premise here, because there's the period, and then it goes straight into therefore. So what do we got? If, that's connective language. That means there's going to have to be a symbol there. A shape is a square. then there's a then it cannot be a circle. Let's stop there. What's premise number one then? We've got this. Okay. If a shape is a square, that means whatever follows if goes on the left side of the arrow, then it cannot be a circle. Okay. Assumption number one. And hopefully that makes sense, right? If it's a square, it's not going to be a circle. Okay, those things do not work together. All right, then we got this. Therefore, that means here's what we're solving for. I'm going to just stick this over here for now. Therefore, what? It is impossible. Now that the way it's rendered here is the whole thing is italicized. That means it's impossible means the following stuff can't work together. For it to be both, so impossible for both. What does that mean? It's impossible for it to be both a square and a circle. So impossible for both means if I say something like this, A and B, you can have both. If I say you can't have both or it's impossible for both, that means this and here, nope, you can't have that. It's impossible to have both these things. That's what this would mean here. So if I were to cover the squiggle, yeah, both of these. What does this mean? Not both. You can't have both. Okay? So what this is saying is, what we're solving for is, you can't have something that's both a square and a circle. You can't have something that's both, you can't have a shape that's both a square and a circle. Okay, so that's what we're solving for. So we've got this assumption, we want to get this. In fact, later on in the semester, you're going to learn a move that allows you to switch between these in one move. Okay, it might not be obvious yet that it's the case, but yeah, if you've got a shape and it's not a circle, then it's the case that, you can't have something that's both a square and a circle. So what are the moves that we got in view? We got arrow out, Modus Tollens, and out, and those are kind of the package deal of can we do these, do them. Then the next set, and in, double negation, if you really have to. If you find yourself in a situation where you need to do these, do them. And then we've got the emergency situations. Arrow in, if our goal is an arrow, it's not here, so that's not going to happen, at least at this moment. And then indirect proof, if we can't do anything else. So let's take a look. Do we have an arrow, not in parentheses? Oh, very much so. Do we have a left side match? Nope. Do we have a right side contrary? Do we have a C somewhere? Do we have either an S that would be a left side match? Do we have a C that would be a right side contrary? Nope. Is there a dot we can break apart? Nope. Can we do an and in? Not even if we wanted to. Can we do a double negation? We could, and get all of this with a set of double squiggles in front of it. That leads us nowhere. Is our goal an arrow? Nope. So what do? Indirect proof. What do we do in that situation? Well, we provisionally assume the contrary of our goal, and then we seek out a contradiction. So what would be the contrary of squiggle S and C? If I'm saying not S and C, what would be the opposite of that? It would just be plain old S and C. Now you could say it would be, well, actually it would be squiggle squiggle S dot C, and then you could do a double negation on that, and then you would have this. That's fine. Okay, when you're translate exactly as is. But I think here when we're dealing with direct opposites, if you can, I think that's obvious there. I think that's intuitive. So I'm going to say here's our provisional assumption for an indirect proof. So we got our provisional assumption. What are we after? What do we want to get now? Any contradiction. Any two contraries that we can slap together with an and in. So that's the mission right now. That's the side quest. So now, go back to the top of the list. Arrow out. Nope. Modus Tollens. Nope. And out. Yeah, that's a new dot there. Unburdened by parentheses. What's it do? It breaks down into these two things. We get S and we get C. And out on line 2. Also and out on line 2. And actually we have two routes that we can go here and we win. Okay, it doesn't matter. Now look, we have a left side match and we actually have a right side contrary. Either route that you go will solve this problem. However, for the sake of being consistent, you can do it the other way if you want to see how it works. For the sake of being consistent, I'm going to follow this list. Because this list, until we get later on, this list as it is here, will always yield the most efficient results. Here it ends up being just as efficient, whether you do a modus ponens or an arrow out in the next line, or a modus tollens. Okay, so it's kind of a choice. If you're feeling dangerous, you can do it the other way. But here I'm going to be consistent and say if you can do this thing, go ahead and do it. So do we have a left side match? Yes. What does that get us? Squiggle C. And if you did the modus tollens instead, you would get a squiggle S, in which case you'd have S and squiggle S. But as it is for us now, doing it this way, we already got that C and squiggle C. How do we get this here? Arrow out, 1 and 3. which means, by the way, since you can go another route, if you did the other route, it'd be just as correct. There's not bonus points for doing it this way. Okay, it's just as efficient, takes just as many steps. If it's a matter of preference for you, that's fine. And the way logic works is if you can do it, it's fine. Okay, it's just as correct. But I'm going to do it this way. So yeah, we got squiggle C, arrow out 1 and 3. Okay. Now, look, there are my contraries right there. But just to be consistent, can I do an arrow out? I did it. Can I do a Modus Tollens? I can, but I don't need to because I've already got the pieces that I need. Okay, and you can see that. So maybe you might get the squiggle S out, in which case you'll have 2 sets of contraries. Take your pick. But I know what I need to build here. It's right here, and I knew this when I started this indirect proof. There it is. That's what I sought. Okay, I was seeking this. Here it is. So let's go ahead and stick it together. C and squiggle C. And in. Oh, they're right next to each other. Very convenient. 4 and 5. Okay, side quest complete. I provisionally assumed the opposite of my goal, and I got a set of contraries, which a set of contraries is a contradiction. So what I'm saying here is, if this is true, it leads to nonsense, because contradictions are stupid. Which means, if this is true, if this leads to this, then its opposite must be true. Then this is really true. So what I do is I zoom out, and I say, yep, we've proven this, albeit indirectly, and what I mean by indirectly is if the opposite were true, it would lead to nonsense. So we can say indirect proof, where do we start that quest? Line 2. Where did it stop? Line 6. Okay, let's look at the final one from the Quiz 4 prep. Okay, let's take a look at this final one from the Quiz 4 prep here. So here's what we got. What this means is, and it's what it's laid out like this, as it's been laid out in Quiz 3. That's the first assumption, that's the second assumption, and then this thing here, that sideways T, means here's what you're looking for, this. So let's write it out. Line 1, squiggle L, arrow M. Line 2, squiggle L, arrow squiggle M. Okay, and these are our 2 assumptions. And what are we after? Just plain old L. Okay, moves in play, arrow out, Modus Tollens, and out. Again, that's kind of a package deal. Then we got the weird ones, and in, double negation. Use them if you have to. And then we have the emergency use only. Arrow in, and then also indirect proof. Alright, let's do the work. Now, also, this is another one that later on in the semester, we'll actually be able to finish this in step 3. There's a move that allows you to do this. And you might see it. Like, look, if squiggle L is leading to M, but squiggle L is also leading to not M, then squiggle L is itself ridiculous. There's an indirect proof hiding in here already. Like, listen, squiggle L is stupid because it leads to both M and not M, and those are opposites, so then L must be true. That's what's going on here. So we already know that it's provable. Let's make it work, though. Let's actually prove it. So first of all, do we have arrows, not in parentheses? Yep. Here and here. Any left side matches, any squiggle L, not to be found. Modus Tollens, is there a squiggle M by itself? There is one here, obviously. Is there a squiggle M by itself? No. Is there just a vanilla M by itself? No. That's constrained. Got a pair. Do we have a dot we can slice in half? No. Can we build with an and? We can, but that gets something way more complicated than what we need. Double negation. Again, it is an option, but it doesn't lead anywhere. Is our goal an arrow? Nope. So what are we going to do? Provisionally assume the opposite of our goal and get a contradiction. So let's do that in step 3. What would be the contrary of L? Squiggle L. You can see that's already going to be convenient. So provisional assumption. And what are we after? Any contradiction. It doesn't matter what we get. So now, can we do an arrow out? Yeah, 2 sets. Let's go ahead and do the work there. We get immediately M, arrow out, 1 and 3, and also squiggle M, arrow out, 2 and 3. And hopefully you can see, like right there, that's exactly what we need for this. There are contraries right there. To be consistent, can I do another arrow out? Yeah, I did them all. Modus Tollens, can I do those? Yeah, but you're just going to get the same stuff you already have. Well, I've got an M here. That's the opposite of this. Then I can get squiggle M, but you already got it, so it's definitely not needed. You could do it. It wouldn't be wrong, but it'd be redundant. Okay, so I wouldn't take points off for it, but we can be done much more efficiently here. There are the pieces. Let's go ahead and build it with an and in, because remember, indirect proof always ends with an and in. Okay, so I can say M dot squiggle M. And I just say, yep, I did that. I stuck them together. Where'd I get the pieces? 4 and 5. So that means squiggle L is stupid, because if you get it, it leads to nonsense like this. M's are also not M's, which means if that's the case, we can zoom out and say, that means If this leads to nonsense, then its contrary, L, is a thing, albeit we proved it indirectly. Okay, where did it start? The game started in 3. We finished in line 6. So these have been 4 problems that we've done for quiz 4, and so all the problems on there are going to be ones that play out like these 4 example problems that I've had here. I think these are less intensive than the ones in the book, but if you can do the ones in the book, it'll prepare you greatly for the ones on the quiz. And so that concludes the stuff on negations here. So negations aren't going anywhere. Now negations are going to stick around for the rest of the semester. But the next thing we're going to move on to is the notion of biconditionals. Double arrows. Let's see how that goes. All right, so see you next time. We'll talk about biconditional statements.